Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we're going to talk about how to construct confidence intervals for population means. All right. And so in the last video, we talked about the student's t-distribution. And the student's t-distribution is important for calculating confidence intervals. We have to use that, but we can only use it if a few criteria are met. And the first one is if we want to construct a certain level of confidence interval for the population mean, these three things have to be met first. First, the sample data has to be a simple random sample or a randomized experiment. The sample size has to be small relative to the population size. If you know the population size, multiply by 0.5. And if your sample is less than or equal to that, then it meets that criteria. And then thirdly, the data has to come from a population that is normally distributed or the sample size is large, all right? If those three things are met, then you can construct a confidence interval using these formulas. So your lower bound is found by doing the sample mean minus the critical t-value times the sample standard deviation divided by the square root of n, and the sample mean plus the critical t-value times the sample standard deviation divided by the square root of n. All right, so t of alpha over 2 is the critical value with n minus 1 degrees of freedom. So exactly how do we use that? Let me show you. Oh, before I can show you, so now the margin of error is that part. So if I go back, the margin of error is the part that we're adding and subtracting on here. So it is the critical value times the sample standard deviation divided by the square root of n. So now there's something else that has to be met before. So not only do those three criteria formally discussed have to be met, but we also have to verify that our sample data is normal or somewhat normal. This is really the third one here. The data have to come from a population that is normally distributed. So we have to also verify that our sample data is normal before we can use students' t-distribution. So if n is greater than 30, then we know by the central limit theorem that the sample data will be approximately normal. We talked about that previously. So there's no issue if n is 30 or greater. It's when n is less than 30 where we have to verify this. So if n is less than 15, then what we'll do is we'll use students' t-distribution to construct confidence intervals about the population mean only if the sample data are symmetric with no outliers, okay? So what we'll have to do is we'll have to use a box plot to verify that it's symmetric with no outliers. If it is symmetric with no outliers, this means that the median is in the middle of the box and the whiskers should be of equal length, all right? We talked about how to make box plots in another video previously as well. Now, if n is between 15 and 30, you don't have to, it doesn't have to be symmetric with no outliers. It just can't have extreme skewness and no outliers, okay? So extreme skewness means like where almost the whiskers is mainly on one side, okay? That's extreme skewness. And outliers, it can't have any, all right? And that's if n is between 15 and 30, your sample size. So now here's an example. The website fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in Table 3 show the reported miles per gallon of 2014 Toyota Camry automobiles for 16 different owners. We want to treat this sample as a simple random sample of all 2014 Toyota Camry automobiles. And then we want to construct a 95% confidence interval for the mean miles per gallon of a 2014 Toyota Camry, and then we want to interpret the interval, all right? So we have a simple random sample. So now let's go back through our criteria to make sure that it is met. We have a simple random sample. That's one. Two is that our sample size should be fairly small relative to the total population. Now, I don't know exactly how many 2014 Toyota Camrys there are, but I'm sure there are more than... I'm sure that this sample size is less than 5% of that population, okay? If I was to do 16 divided by 0.05, I would get 320. So that means 320 is the number that 16 should be less than. And I'm pretty sure there are more than 320 Toyota Camrys. So that second criteria is met. And then, and just in case y'all wonder what I'm talking about, let me go back really quick. That second criteria was here, where your sample size had to be less than or equal to 0.05 of the total population. And so I took 16, which was my sample size, and divided by 0.05, and I got 320, which says that my population size needs to be 320 or bigger. And I'm pretty sure there are more than 320 2014 Toyota Camrys driving around here, okay? So that's the second thing. And then the third thing is the sample normally distributed. Well, our sample size is not bigger than 30. It is 16. So if I go back to this slide, if n is between 15 and 30, this is where my 16 will fit. Then all I just need to make sure is that there is no extreme skewness and that there are no outliers. And if we create a box plot with this data, which I'm not going to go through the steps on how to do it, but if we do, this is what our box plot will look like. And as you can see, it is not symmetric because the median is here. However, it does not have no outliers. There are no outliers because remember, outliers will be marked out here with stars. And it does not have extreme skewness. Extreme skewness would mean that the whisker on one side is like way longer than the one on the other side. In this case, it's a little longer on this side, but it's not way longer, okay? So our three criteria are met, and so now we can use students' t-distribution to find the confidence interval. So before we go there, we have a 95% confidence interval. So that means, and if we go back, that means we need to find t of alpha, which in this case our alpha, or t of alpha over 2, which in this case our alpha is 0.05 because you do 1 minus 0.95 and you get 0.05. So we want to do t of 0.05 over 2, which is equal to t of 0.025, okay? So that's the critical value we have to find, t of 0.025. And then we also need to know the degrees of freedom. Remember, the degrees of freedom is going to be n minus 1, and our n is 16. So 16 minus 1 is 15. So we want to find t of 0.025 and with 15 degrees of freedom, okay? So I'm going to my t-chart and I'm going to look for that. So 0.025 is here. And I want to go down to 15 degrees of freedom. And that value is 2.131. Okay. Now, what I'm doing is I'm using the formula. Let me go back to it so y'all can remember. I'm using this formula to find my lower and upper bound. Here's my lower bound. Here's my upper bound. Notice that my formula has the sample standard deviation in it. So the next thing I need to do is calculate the sample standard deviation of these numbers in this chart. So I'm going to go into Excel to that. So I have put these numbers into Excel and I'm going to type in equal STD, and I want the .S1 that stands for sample, and I'm going to double click on it and highlight my numbers. I'm going to close the parentheses and hit enter. And this gives me my standard deviation, my sample standard deviation. That's what I have right here. And that is, if I round it to 2 decimal places, 2.38. Okay, so that's the sample standard deviation I want to use. So I'm going to find the margin of error first. My margin of error is going to be my t alpha over 2 times my sample standard deviation divided by the square root of n. Well, we calculated t of alpha over 2 by finding it in the chart. It was 2.131. We just calculated the sample standard deviation in Excel. It's 2.38. And then divided by the square root of n. N is 16 because that's our sample size. So if we calculate that, 2.131 times 2.38 divided by 4, because the square root of 16 is 4, you get it to be approximately 1. That's 2 squiggly lines for approximately 1.2679. That's my margin of error. So to find my upper bound, I need to know my point estimate, which is my X bar, which we calculated in Excel. Also, I didn't show you. Let me show you really quick. Well, no, I'm not going to go back because this is going to erase. But in Excel, I don't know if you paid attention, but I had the mean above the standard deviation, and it was 28.1. So to find my lower bound, I'll do the My lower bound is going to be equal to my point statistic, 28.1, minus my margin of error, 1.2679. And my upper bound is going to be equal to my point statistic plus my margin of error, 1.2679. So when you work that out, you end up getting 26.83 for the lower bound, and the upper bound ends up being 29.37. Sorry, that zoomed in, but my lower bound is 26.83 and my upper bound is 29.37. All right, so what does that mean? That means we are 95% confident that the mean miles per gallon of all 2014 Toyota Camry cars is going to be between 26.83 and 29.37 miles per gallon. All right, that is how we will find the confidence interval for 95% confidence interval for the mean miles per gallon. Sometimes we need to determine the sample size to get a certain confidence interval, level of confidence for a confidence interval that we want. And this is the formula to find it. We are looking for the population mean. Okay, so the sample size is equal to the critical Z value times the sample standard deviation divided by the margin of error that we want squared. And you always round your n up to the nearest whole number. So here's an example. Using that same example we used, the website fueleconomy.gov allows drivers to report the miles per gallon of their vehicles, and we still have the 16 samples from 16 different owners. But this time we want to figure out how big of a sample will we need to get a 95% confidence level with a margin of error that's within 0.5 miles per gallon. All right. So in order to get a 95% confidence interval, we need to know the critical value for that. And the critical value is going to be this 1.96 if we use this level of confidence table. So recall that the formula is N equal to our critical value Z of alpha over 2 times our standard sample standard deviation divided by our margin of error, all of that squared. So our critical value we just found out was 1.96. We calculated our sample standard deviation and got 2.38. And then the margin of error is this 0.5 that's given in the problem, 0.5. That's this. We want it to be within that range, and so we're going to square that. So you're going to do 1.96 times, that's a multiplication symbol, times 2.38, trying to make it darker, divided by 0.5, that is a decimal right there, 0.5, and then you're going to square that, and you end up getting about 87.04, and you round it up. And so when you round it up, you get N equal to 88. So that means you need to take a sample of at least 88 2014 Toyota Camry owners in order to get a 95% confidence interval that is within 0.5 miles. So 0.5 miles both ways. All right. So this is how you will find the sample size if you need to get a specific confidence interval. If you have any questions, please don't hesitate to reach out. Let me know if you have any questions. Thank you for watching, and I will see you all in the next video.